So as you know, the quadratic equation in standard form is y equals ax squared plus bx plus c. Okay, and that's when a cannot equal 0 because your ax squared term is your quadratic term. So if a were equal to 0, then you would lose your quadratic part and you'd bump it down to just a bx plus c, and that bx is your linear term. So you got to have that x squared for it to be quadratic. And then c is your constant. Okay, so if I look, this is when it looks like whenever it opens up. This is what it looks like when it opens down. We already know that. This x equals negative b over 2a is a new formula you're going to have to memorize. That is the formula for your axis of symmetry, which is also going to get us the x value of the vertex. Okay, so what we're going to do is use that formula first to find the x value of the vertex. Once we get the x value, you're going to plug it into the equation to get the y value out. Okay? If you have a decimal for the y value of the vertex, that's okay, but that's the only thing that can be a decimal. Everything else needs to be whole numbers in your table. Okay? We're going to talk about your max and min, domain and range, and our transformations. Okay? So, first, we're taking x equals negative b over 2a. Remember that it is ax squared plus bx plus c. So when I do my negative, that is completely separate from the negative with my b value. Okay? That negative and that 2 is part of my formula regardless of what my values are. Okay, so I'm going to plug in my negative 8 for b, and I'm going to plug in my negative 2 for a. So a negative 8 is just 8 divided by negative 4, which is going to give me negative 2. So I do know that that is my axis of symmetry, x equals negative 2. If you want to go ahead and answer that part, you can. Then what I'm going to do is I'm going to take this negative 2, and everywhere there is an x in my equation is what I'm going to plug in. So I'm going to have f of negative 2, which is just function notation, the value of the function at x equals negative 2. And then I've got negative 2 times, in parentheses, negative 2 squared minus 8 times, in parentheses, negative 2 plus 1. Okay, you can type that in your calculator. And it gives you 9. So I'm going to put those two values together. My vertex is negative 2, 9. Okay? I'm going to build my table next with my vertex in the middle, and then I'll answer all my questions later after I graph it. But that negative 2, 9 goes in the middle. If I look at my a value is a whole number, so I know I do not need to skip any x values, so I can use negative 3, negative 4, negative 1, and 0. Okay, so remember in your calculator, you can store these x values and then type this. So that's how we're going to build our table, if you don't remember. Okay, so I'm going to take negative 3, and then remember the store button is next to 1, and then x is right above that. And then I'm going to type in negative 2x squared minus 8x plus 1. So negative 3 is going to give me 7. And then I'm going to store negative 4. And remember, you can hit the up arrow till that equation is highlighted. Press enter, enter. Y'all remember doing this? Okay. So negative 1, store for x. Go up and grab it, and that also gives me 7. 0, store for x. Should also give me 1. Okay, then I'm going to graph that. What else should I have on my graph? Okay, and remember your axis of symmetry is that vertical line that cuts through the center of your graph. It's dashed and it's got arrows. If you don't have your axis of symmetry, I'm taking points off because 1, your homework is not complete without all parts, and 2, that is going to be important, especially when we get to intercept form. Okay, now I can look at, do I have a max or a min? I have a max. Remember, you can circle it, but what else do you have to do there? You have to tell me the value. It's a max at y equals 9. What's my domain? Or if you used Set Builder, who uses Set Builder? Okay. I'll still write it then. Alright, so my range, if I have a maximum, then that means I start down here, negative infinity to 9. Or for my set builder, y is less than or equal to 9. Okay. I didn't leave much space for me for transformations, but if all you have is that, you should have plenty of space for your transformations. Okay. So now you can look at your a value still. My a is -2. So that negative tells me I have a reflection. And then I look at only the 2. Okay, not the negative, but the 2 tells me what? It's a vertical stretch by a factor of 2. Remember, we're tacking that on. Okay, then I can look at my vertex. Okay, for my translations, I can either look at my graph or I can look at my vertex. I like to look at my vertex, and if it's a negative for my x, that means I shifted where? Left, 2. And then if it's positive, right. So don't get that confused with whenever we're looking at vertex form. Okay, vertex form is the opposite of, because we're looking at the equation. But if you're looking at just the vertex, that tells me from my origin, which is where my vertex is from my parent function, I had to move left 2 and up 9 to get to my new vertex. Okay, so it shifts left 2 units and up 9 units. You're good with that? Okay. Alright, so we're going to do the same thing. I'm going to start with my x equals -b over 2a. What's my b value that I'm going to plug in? -4, and my a value? -1/2. So in your calculator, you can either type it or you can do the mental math. If you want to type it, remember that n over d gives you your fraction template. So I've got negative parentheses -4 over 2 parentheses, hit the fraction button again, -1/2, which should just give you a -4. Alright, so my axis of symmetry is x equals -4. I'm going to take this -4 and do what with it? Plug it in everywhere there's an x. Okay, whenever you plug it in, you should get 9. Is that what y'all get? Okay. So my vertex is -4, 9. So that's going to go in the center of my table. Now, I've got a fraction for my a. That means if I were to store -5, what do you think is going to happen? A decimal or a fraction. Okay, am I going to use that? No. I'm going to skip to -6. I get my whole number, so that's what I use. So do you think that -7 is going to work? No. So when you have your fraction, remember you're more than likely going to skip. Okay? So -8 stored for x will give me the 1. So in the opposite direction, what are the x values I'm going to use? So I want to make sure that I do get the same y values. Okay, then I'm going to graph that. Then I'm going to put my axis of symmetry. Do I have a max or a min? At? Okay, what's my domain? Okay, what's my range? Or y is less than or equal to 9. Okay, my transformations. Reflection, because of the negative. Vertical shrink by a factor of 1/2. And then my vertex tells me it shifts where? Left 4 units and up 9. Very good. Do we have any questions on that section? Okay. Bless you. Okay, now what if we have standard form, but I tell you I don't want you making a t-chart. Okay, I don't want a table. We're still going to use our x equals -b over 2a for the x value. We're still going to plug that in to get the y value of the vertex. But now we're going to use the y-intercept in a point of symmetry. Okay, so the y-intercept is your c value in your standard form function. So if I have ax squared plus bx plus c, well, why is it just c? So, because it doesn't have x, what gets rid of my x? What is the y-intercept? Where it crosses the y-axis. What's your x value when it crosses the y-axis? 0. What happens when I plug in 0? Your x's go away, so you only have c. So that's the reason behind me just telling you, hey, it's c. Okay? But if you can just memorize that, then you're good. You don't have to plug in a 0. Okay? Now, what we're going to do is we're going to use that y-intercept, and we're going to use our axis of symmetry to find a point of symmetry. Okay? And then from there, you just graph it and do your domain and range, because technically you only need 3 points to graph a parabola. So we're going to have our vertex, y-intercept, point of symmetry. Okay? So my starting negative b over 2a point, I've got what for my b value? Negative 8. And my a value? Negative 2. So 8 divided by negative 4 is negative 2. So f of negative 2 that gives you 5. So my vertex is negative 2, 5. My axis of symmetry is x equals negative 2. So my y-intercept is going to be 0 what? Negative 3, because it's the c value. Okay? So I'm going to plot my negative 2, 5. I'm going to do my axis of symmetry through that vertex. And I'm going to plot my 0, negative 3. Okay? Now I'm going to look. I'm going to start at my axis of symmetry, because that's the smack dab middle of my graph. That cuts it in half. So if my y-intercept is 2 points to the right of my axis of symmetry, where do you think my point of symmetry is? 2 points to the left. So you're going to use that axis of symmetry, count the points, and you create your point of symmetry, which is at negative 4, negative 3. And then draw your parabola. My domain stays the same, all real numbers. What's my range? Or y is less than or equal to 5. Y'all good with that? If your instructions don't say it, you don't have to. I think y'all are good at this point to identify transformations. Okay? If your instructions say to, then yes. But if it doesn't say to, then no. So go back to your instructions. Make sure you've answered everything you're supposed to. Alright. Intercept form. If I have two x-intercepts, this is what it looks like. Okay, if I have one x-intercept, then my vertex ends up being my x-intercept. Okay? We're going to have a section where we actually analyze what's happening when we predict this kind of stuff, but for now, you're just looking at what happens. Okay? If you have no x-intercepts, then it's going to be either all above or all below your x-axis. Okay? We're going to get into a section later on in the year with imaginary numbers, and so this is a situation where you have two imaginary roots. So we're going to get to that, but for right now, that's all you need to know. Okay? Now your intercept form is f of x equals a times x minus p times x minus q. If you remember factoring, this kind of looks like what your stuff should have been when you factored. So like x minus 2, x minus 3. And do you remember setting that equal to 0 and solving it? You were solving for your x-intercepts. Okay, so this is intercept form. Alright? Where p and q are your x-intercepts. So all you need to know is that you're basically taking the opposite sign of what's in your equation. Okay? If you wanted to set x minus p equal to 0 and solve to get x equals p, You can, but I don't think that it's necessary. Okay? All you're doing is changing the sign because of the fact that you would be doing the inverse operation here, which is the opposite of what's being done. So, therefore, you're doing the opposite sign. All right, you will list them as ordered pairs. Okay? And the axis of symmetry is going to be between those two x-intercepts. So we're going to have a new formula that you have to memorize and know when to use, when not to use it. And all that is you take your two x-intercepts, you add them and divide by 2. Okay? So p plus q divided by 2. That's going to give you your axis of symmetry, which is the x value of your vertex. Okay? Then once you get the x value of your vertex, same thing, plug it in and get the y. Okay? So here, f of x equals negative 2 times x plus 3 times x minus 1. My x-intercepts are going to be what? Negative 3, 0, and positive 1, 0. I'm taking this plus 3, changing the sign, and it's a negative 3. I'm taking the minus 1, changing the sign, it's a positive 1. Alright? Now, for the x value of my vertex, I take my negative 3 plus my 1 and divide it by 2. So negative 3 plus 1 is that p plus q. Okay? That gives me negative 2 divided by 2, which is negative 1. I'm going to take this negative 1 and I'm going to plug it in for my x's. So f of negative 1 is equal to negative 2 times negative 1 plus 3 times negative 1 minus 1. So negative 2 times negative 1 plus 3 times negative 1 minus 1 gives you 8. So my vertex is negative 1, 8. So I'm going to plot my negative 3, 0 and my 1, 0. And my vertex is negative 1, 8. If you draw your vertex and axis of symmetry and it's not in the middle of those two x-intercepts, then something is wrong with your math. Okay? It should be in the middle of those two. Okay, domain does not change, negative infinity to positive infinity, or my XER for all real numbers. My range is going to be what? Or if you're doing set builder, y is less than or equal to 8. Are y'all good with that? Okay, now I've got f of x equals negative 2x times x minus 3. Okay, what are my x-intercepts? Alright, so I've got this x right there. If I were to set negative 2x equal to 0 and solve it, divide by negative 2, x would equal 0. Alright, so if I have an x that does not have something added or subtracted in parentheses, that's just going to give me 0, 0. Okay, and then my second x-intercept, I don't know why I keep saying y-intercept, second x-intercept is 3, 0. Okay, so then to solve for my x value of the vertex, I'm going to take 0 plus 3 and divide it by 2. That's 3 halves, which for right now, since we're going to be on a graph, you can do the decimal 1.5. So then I'm going to have f of 1.5. Remember, your vertex is the only time you can have that decimal. So that gives me 4.5. So my vertex is 1.5, 4.5. So plot that and plot your two x-intercepts. Your axis of symmetry cuts through the middle. My domain, negative infinity to positive infinity. My range, negative infinity to 4.5. Or y is less than or equal to 4.5. Every single one of those examples up and down. Did not plan that. But y'all know how to do your range when it opens up, right? Okay. Are y'all good with that? Okay, we're going to move on to word problems because you're going to have word problems. It's quadratic. Okay, quadratic is the most like realistic that you can have. Bridges, projectile stuff. Are y'all in physics? Y'all aren't in physics yet. Y'all have that. Y'all are in physics? Some of y'all. So physics has a lot of quadratics in that. Okay. So you're going to have word problems on your tests. You've got to be able, and they're not hard, but you've got to be able to think realistically. Okay. You're meshing your algebra and your realistic thought process. Okay, so this tells you that the parabola here shows the path of your first golf shot, where x is the horizontal distance and y is the corresponding height. The path of your second shot can be modeled by the function f of x equals negative 0.02x times x minus 80. Which shot travels farther before hitting the ground, and which travels higher? Okay, well this one right here travels how far? How far? 100. Okay, so it travels 100 yards. I was about to say feet. Okay, that's how far. Now how high? 25. So how high is going to refer to your vertex. Okay, remember your vertex is your highest or lowest point. So if something is asking if something can pass over something, or how high, or what's the maximum of something, it's referring to your vertex. Okay, that is your key component of a quadratic. Now, if it's talking about how far, that's your what? X-intercept. Okay, so you got to think, this is what I'm talking about, you're meshing and combining your realistic and what that means, and visually what that is, versus your algebraic components of a quadratic. Okay, so we're going to look at this function, and what do you think I need from this? If I'm going to compare them, what do I need? What did I just use here? My x-intercept. So I need to know what my x-intercepts are. Well, they're what? 0, 0, and 80, 0. Okay. What else do I need? I always need my vertex. Even if you don't think you do, you probably do. Okay? So, my vertex, how am I going to find that? I have to find my x first. How am I going to find my x? So, 0 plus 80 divided by 2 is going to give me 40. And then what am I going to do with that 40? I'm going to plug it in. And you should get 32. So my vertex is 40, 32. Okay, so remember that your vertex is halfway through. So if I just drew an arrow here and I never gave you this information, how could you figure out how far it is? Your vertex, you have to know your vertex is in the middle. So if it traveled 50 to get to the middle, then it's going to travel another 50 to be at the ground. Okay? You've got to think about more than just graphing, because so much of algebra, you just are given the information and you do the work and you're done, check it off, and you don't think about what you're actually doing. Okay? So you have to actually expand what you know about what a vertex is and about what your x-intercept is to be able to do these word problems. Okay? So what this is telling me, if I were to draw it, you don't have to, but if you were to draw it, you've got this, okay? And so my vertex tells me 40, 32. And then my x-intercept tells me it's at 80, 0. So we're going to see which one traveled farther and which one traveled higher. First shot or second shot traveled farther? How do we know that? Your x-intercept is 100 versus 80. Okay? Which one traveled higher? How do I know that? My y value of my vertex, 32, is higher than 25. Okay, so before you get to a word problem and you just, I don't know what I'm doing, think about, that is very easy. You have to think about what you're given in the characteristics of a quadratic though. Okay? You don't have any questions?